In this lesson, we'll learn what statistical arbitrage is. Recall from the previous lesson that in finance, arbitrage is the concept of profiting by exploiting price imbalances. Recall also that when the profit from an arbitrage opportunity can be determined from the start with complete certainty, meaning there is no risk involved at all, then the arbitrage is deterministic. An arbitrage opportunity is statistical if the profit from it cannot be determined from the outset with absolute certainty, meaning there is risk involved. This means we expect theoretically to make a particular amount of profit, but in practice we're uncertain to realize our expectation because there's risk inherent in the situation. Let's understand this with an example. Say there's a game where a fair six-sided die is rolled and the player receives the dollar value of the number that's rolled. If a 1's rolled, then the player receives $1. If a 2's rolled, then the player receives $2, and so on. Say the game costs $3 to play per go. Then the possible outcomes of a roll are as follows. If we roll a 1, we suffer a loss of $2. If we roll a 2, we suffer a loss of $1, and so on. We can't say for certain how much we'll win or lose in this game because we can't say which number we'll roll. There's risk and uncertainty involved. We know there are 6 numbers on a die and the die is fair, so the chance of any number being rolled is equal and is 1/6. If we play this game once only, then the 1/6 chance value is meaningless and irrelevant. We could be very unlucky and end up $2 out of pocket because we rolled a 1. Or we could be very lucky and end up $3 better off because we rolled a 6. However, if we play this game repeatedly, then the 1/6 chance value becomes meaningful and relevant. Then we expect rolled numbers to average out to 3.5, meaning we expect to receive on average $3.50 and thus make an arbitrage profit of 50 cents per play. Note that our expectation of a 50 cents profit can never be realized on any single play because a die doesn't have a face with 3.5 dots on it. A 3.5 can never actually be rolled and we can never actually make a 50 cents profit on any single throw. So understand this, an average, or an expected value as it's also known, is a theoretical value. It may or it may not be one of the possible outcomes. What we have in this game is a theoretical arbitrage profit opportunity of 50 cents per play. After 100 plays, we expect to make $50 theoretically. However, our expectation is not guaranteed to materialize. The $50 profit is a theoretical result based on the 1/6 probability of each number being rolled. The number of times each number actually gets rolled may be somewhat different to what the probabilities suggest. But the more times we play, the more the probabilities will get borne out and the closer will our profit be to our theoretical expectation. This is the nature of probabilities. They're based on the notion of infinite trials. After 1,000 plays, we expect to make $500 theoretically. After 10,000 plays, we expect to make $5,000 theoretically. So we should keep playing this game over and over again, infinite times, because then we'll make an infinite profit. As we play this game more and more times, the game operator will suffer an increasing amount of loss. This ought to trigger him to review the price per play and increase it to $3.50, where the statistical arbitrage opportunity disappears. At $3.50 per play, there is no arbitrage opportunity. Players will be indifferent to playing, and the organizer will be indifferent to operating this game. This is the importance of statistical arbitrage. Like deterministic arbitrage, it too drives imbalanced prices back into alignment. Can you appreciate that if the price per play is more than $3.50, then the game operator is the one who expects to make the profit? You might think nobody would play the game if it's priced above $3.50 per go, but you'd be wrong. The gambling industry is built on this type of statistical arbitrage opportunity in favor of the operators. To take advantage of statistical arbitrage opportunities, the following three conditions are necessary. Correct outcomes and probability values. They're needed to determine correct expected values. In this very simple die game example, it's possible to determine the outcomes and their probabilities absolutely, because everything about the game is known and understood fully. There are exactly 6 outcomes, each with the same probability of occurrence. However, in investment scenarios, some possible outcomes and their probabilities might have to be estimated or guessed, or might not even be known about until after the event. Another condition is a large number of goes or plays, so the probabilities become borne out. Finally, sufficient funds are needed to be able to keep playing. A series of loss-making outcomes might occur before any profiting ones. If the losses incurred wipe out the funds needed to keep playing, then the large number of plays necessary for the probabilities to be borne out is prevented and the expected profit can never be realized. I'm Balbinder Chagga, the author of Options Explained Simply, from where this lesson is taken. You may look inside Options Explained Simply on your local Amazon. You can also find out a bit more about me on my authors page on amazon.com/author/Chagga. If you found this lesson useful, then please do click the like button and share to your network. Thank you.